discuss the very important chapter, chemical bonding. We'll discuss that in this chapter. We'll go with that. Chemical bonding. In this first, we'll discuss with Vsepr theory. Second will be hybridization. And third will be molecular orbital theory. And fourth will be dipole moment. So the chemical bonding consists of four important topics. One will be Vsepr. What is Vsepr? Valential electron pair repulsion theory. Next is hybridization and molecular orbital theory. And next last will be dipole moment. It's a very important chapter. So listen carefully. We'll go one by one. First we'll go with the Vsepr theory. What Vsepr theory says that? Look at Vsepr theory. What this theory says that? This theory that gives the information about the structure of or shape of covalent molecule. How they are finding out the shape of covalent molecule? I'll give some example. From the example, you can able to understand. Look at this. Now let us take that. He has taken AB2, has taken as AB3, and he has taken as AB4, has taken as AB5, and he has taken as AB6, and he has taken as what I can take AB7 also. Look at this. Here the central atom is what? A. If the number of electron pairs which decides what we can say, which is surrounded by central atom, which decides the shape of the molecule. Now look at this. Now I can write A. I can say this is B. Here is what? Now I can say A, B, B, B. And if I'm writing this A, look at this B, this is B, this is B. Here is what? What is the meaning of number of electron pairs? We can talk about number of lone pairs plus bond pairs, which decides the shape of the particular molecule. That means the shape of the molecule decided in the how many electron pairs are there. In the electron pairs, if all are bond pairs, they have the perfect geometry. If the lone pair is present, they are deviating from the original shape due to the repulsion. So now we will go with the one by one. First I am taking this the example. This is what the central atom. How many electron pairs? 2 electron pairs are there. All electron pairs are bond pairs. So now what is the bond angle? BAB bond angle I can say is what as a 180. That means I can say that the shape of this molecule is called linear. Now look at 3 electron pairs. All 3 electron pairs are is what? Bond pairs. If the 3 electron pairs, all 3 electron pairs are bond pairs, means what we can called as a planar, trigonal planar. Why? The bond angle between these three is what? 120. Therefore, this belongs to is what? Planar. Now look at this. This is the example. I am telling that A central atom. How many electron pairs are? 4 electron pairs. All electron pairs are is what? Bond pairs. Therefore, the perfect geometry of tetrahedron. What is the bond angle between B, A, E? You can say that 109 degree and 28 minutes. That means what that Vsepr theory says that there are 2 categories. One is the molecule which has all are lone pair and all are bond pairs, no lone pair. Other category they have bond pair as well as lone pair. That means electron pair considered as lone pair plus bond pair. If the molecule has 0 lone pair, they have the perfect geometry or perfect shape they have. If the molecule has lone pair as well as bond pair, that means bond pair plus lone pair, obviously they are deviating from the original shape as well as the ideal bond angle. Why? Because of the repulsion. Because of repulsion. Why in Vsepr theory says that in the valence shell, please keep it in valence shell, the electrons are present as a negative charge. They are so when Vsepr theory says that this the angle is maximum, repulsion your repulsion is less there, or we can say stable. That's what the Vsepr theory says. And look at this. Now I'm taking this. Now we take the example of AB5. Look at this. I'm going with that as AB5. In this case, A, I can say this is what B, B, this is B, this is also is what B. Now I can say this is AB4 tetrahedral, AB3 is trigonal planar, and AB2 is what linear. In this case, AB5. Here in AB5, there are two types of bonds are there. One is called axial bonds, another one is called equatorial bonds. Now, I can say these three bonds are called equatorial. And these two bonds are called, what you can say, axial bonds. So therefore, this is trigonal bipyramidal. And the last will be is what? Look at that. And if I am taking that, I'm taking last, I'm taking as AB6. In the case of AB6, listen, A can say that B, this is B, this is B, this is B. That's all. This is called octahedral. That means central atom which has a 6 electron pair. All 6 electron pairs are bond pairs. Therefore, they belongs to is what octahedral geometry. So this is what, or we can say the Vsepr theory says that. Now, can we have some example? I'll give one simple method. That method which makes you to understand. Listen, this method is only applicable for the molecule is not having hydrogen. Let us take the example one by one. Listen. I'm taking one by one. Listen. I'm taking BCl2. I'm taking here as BF3. I'm taking here as CCl4, PCl5. I'm taking a substance. This is what I'm doing. In these, what is the shape of these molecules? Now, the shape is decided by the central atom. Here, central atom is what? Here, beryllium, boron, carbon, phosphorus, and sulfur. You should know the valence electron of beryllium. What is the valence electron of beryllium? I can say that 2 electrons, right? And fluorine, what is the valence electron is 7. How many chlorine is there? 2. 2 into 7, 14. Just add that. 14 is equal to 16. You do divided by 8. Why divided by 8? Because these are all these, or we can say the octet molecule, we can say. Because of that, divided by 8. You divide by 8, look at this, and I'm going to have, this is 2. 2 plus 0. What is the meaning of 2 plus 0? Please understand. This 2 8s are 16. Remainder is 0. That means when remainder comes 0 means we can say that there is no lone pair. This 2 indicates that what we can say bond pairs. Now I'm writing this will be bond pair. This will be what? That means has only 2 bond pairs L and Cl. Class J, live class அப்படியா Yes, children, listen again. This is BeCl2, BF3, CCl4, PCl5, SF6. Now look at this. 2 plus 14 is 16 by 8, which means that 8 divided, why divided by 8? Because the molecules are all are going to obey the octet rule, that's why it's divided by 8. And 16 by 2, if we have that 2 8s are 16, remainder is what? 0. Which clearly says that when remainder comes 0, then belongs to is what? 0 lone pairs. And this indicates that what? 2 bond pairs. That means BeCl2 has 2 bond pairs. When the 2 bond pairs and 0 lone pair means what is the geometry of the molecule? We can say is linear. We can say shape of the molecule is what? Linear. Linear shape. Now, BF3. What is BF3? Take the example of BF3 is boron. Central atom is what? Boron. Now we can say what is the valence electron is what? 3 plus fluorine is what? 7. 3 sevens are what? 21. 21 plus 3 is what? 24. 24 by 8. We know that 3 8s are 24. We can say that as 3 plus 0. What is 3 plus 0? That means in BF3, they have 3 bond pairs and 0 lone pair. Therefore, we can write it as B. This is F. This is F. And this is what F. Therefore, this is what planar. Therefore, bond angle is what? 120. Now, take the example of CCl4, same logic. What is the valence electron of carbon? Same logic. Carbon is what? 4. Plus, I'm taking this is the example 4. What is that? Chlorine. Chlorine has 7 electron. 7 into 4 is what? 28. Extremely sorry here. We can say 7. Yes, 7 for 28. 28 plus 4 is what? 32. 32 by 8. We can say that as 4 plus 0. If it is coming that 4 plus 0 means what we can say, they are called tetrahedral geometry. Look at this. Now I want to play this. Listen. Now I can say this, which clearly says that is what? 4 bond pairs, 0 lone pairs. Therefore, I can write C, Cl, 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 Cl. That's all. That means no lone pair, only the bond pair. They are perfect or tetrahedral geometry. Now come to the point of PCl5. Look at this. Look at this. In the case of PCl5, I'm going with phosphorus. Central atom phosphorus. What is the valence electron? Is 5. Plus this is 7 is the valence electron of chlorine. Therefore 35. That means I can write 40. 40 by 8. What we can say as 5 plus 0. What is the meaning of 5 plus 0? If I am saying the 5 plus 0 means 5 bond pairs, 0 lone pairs. Therefore, they belongs to trigonal bipyramidal geometry. Look at this. Cl, 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 and this is what? Cl. That's all. Now, what is the bond angle between these two? Is what? 90 degree. And bond angle between what is Cl, E, Cl is what we can say as 120 degree. Now we can say this is called axial bonds, and these three are called what? Equatorial bonds. Now, last will be what? SF6. When SF6 means, please keep it in your mind. Central atom is what? Sulfur. What is the valence electron? 6. Plus what about fluorine? Fluorine also is what? 7 electron. 6 into 7 is what? As 42. We can say as 48. 48 by, you can write 8. I can say as 6 plus 0. If it is 6 plus 0, what we can say? It's a octahedral. Yes, look at this. Yeah. 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 And this is what? Yeah. That's all. So bond angle is all is what we can say 90. F, yes, F, F, yes, F, F, yes, F, F, yes, F, F, yes. All is what? Bond angle is 90 degree. It's called octahedral geometry. Fine, sir. So we come to suppose if the molecule has the lone pair of electron, what is going to happen. In that some cases are there. What is the case? I'll tell you that. Now I'll give one small, what is that, tablet problem. Look at this. Just I'll go with that one by one. If I'm having that electron pairs, look at this. Just I will give you idea. Electron pair. Just I will make it 4. And 4 means we can have that what, 4 plus 0. We can have that is what, 4 plus 3 plus 1. And we can say that is what, 2 plus 2. So what is this? 4 plus 0, 3 plus 1, 2 plus 2. What is the meaning of 4 plus 0? That means molecule has 0 lone pair, 4 bond pairs are there. What is 3 plus 1? 3 bond pairs, lone pair. What is 2 plus 2? 2 bond pairs. 2 bond pairs. Here what is that? 2 lone pairs. That means this belongs to, whenever the lone pair is present, what is going to happen? They are deviating from the original shape. It becomes what? Pyramidal. Here this we can say as a bell shape, or we can say as V shape. Now, so can you give the example? Whenever if the electron pair is 4, there are 3 possibilities. One is 4 plus 0, another one is 3 plus 1, another one is what? 2 plus 2. Can you give an example? Look at this. I'm going plus 3 plus 1. 3 plus 1 is the best example is what? I can go with that as, I can take it as HCO3 is the best example. R and T is what? NH3 is the other example. T is 2 I'm going to get. What is HCO3? When I tell you that, I'll tell you that. In this case, you come to the but HCO3. What is the valence electron of xenon? 8. And what about the oxygen? Oxygen valence electron is what? 624. Therefore, 24 we can write as 24 plus 8. 32. Oxygen valence electron is what? Oxygen is S2P5, S2P4. Here I can say it as 18. So 18 means I can write is what? 26. 26 by 8 I can say as is 3 plus 1. So what's that? HCO3. Xenon valence electron is what? 8 is the valence electron. Oxygen valence electron is what? S2P4, 6 valence electron. So which means that what? 6 into 3, 18. I can say 18 plus 8 is 24. 18 plus 18 is 26. 26 by 8 is what? 3 plus 1. Why is that 3 plus 1? 3 8s are 24. Remainder is what? 2. The 2 I am going to keep it as a 1. This 1, the remainder 2 means 1 lone pair of electron. The remainder is 4 means 2 lone pairs of electron. The remainder is 3 means we can say 3 lone pairs of electron, which means that I can say 3 plus 1. 3 plus 1 means what is always the geometry when we get it pyramidal. How? Look at this. I'm going with that HC. I can have this is the lone pair of electron. Look at this double bond group, double bond group, double bond group. Now I can say this is HCO3 geometry is what? Pyramidal. Now come to the point of NH3. Look at this. I'm taking the example of N because it has 5. What we can say? 5 valence electron. In that 3 valence electron take part in the bonding, and 2 will be remained as a lone pair. Now look at this. I'm having this hydrogen. Then having hydrogen. That is what hydrogen. Why this is become pyramidal? What is the reason? Look at this is the lone pair. I can say nitrogen, hydrogen, which is more electronegativity. I can say nitrogen is the most electronegativity. Here I can say what bond pair is goes towards here because of the bond pairs. Look at this. What is happening? This is lone pair. This is what bond pair. We can say the lone pair occupy the more space than the bond pair. Therefore, the repulsion is I can say this is lone pair as well as bond pair repulsion. Here what we have bond pair repulsion. Which repulsion is maximum? I can say lone pair bond pair repulsion is maximum. Therefore, the bond angle decreases by 107. So as per the expectation is what? 4 plus 0 means if the 4 electron pair means what is our expectation? The bond angle is 109. If all are perfect bond pair, because of what we can say that one lone pair is present, it is deviating from the original shape tetrahedral as well as bond angle decreases by what we can say 107 degree. Right or not? If it is coming, please keep it in your mind. As 3 plus 1 if we say, if it is 3 plus 1, pyramidal. If 3 plus 1, We can say sp3 hybridization. We will discuss that. That's all. Now come to the one. What about 2 plus 2, sir? Look at this. In this 2 plus 2, I am going with that as the example of, very simple example of what H2O. H2O. I can take it as, listen, so this is what H, here is what H. That's all. That means we can say that in the valence electron of oxygen has 6 valence electron, 2 will be involved for the bonding and 4 will be remaining as a what we can say 2 lone pairs. Now look at this. If we have the 4 electron pair means what we can say the bond angle could be 109, but here all electron pairs is not a bond pair. We have the 2 lone pair and 2 bond pairs because of what is going to happen. Look at the repulsion. Look at this. In this case, oxygen has what we can say 2 lone pairs, 2 bond pairs, and look at that oxygen, hydrogen, which is more electronegative. So, here oxygen and hydrogen. Look at this oxygen, hydrogen, which is more electronegativity. I can say that this is the more electronegativity. It has. Look at this. Therefore, electronegativity means what? All the bond pairs will go towards the oxygen. Now you can have what we can say 3 type of repulsion. One is nothing but I can say this is lone pair, lone pair. This is lone pair, bond pair. This also lone pair, bond pair, and you have this is what bond. Can say that now we can say that here the lone pair, this is lone pair, bond pair, and here is what the bond pair repulsion, and which repulsion is going to what we can say the going to give us a the which repulsion is going to make it the maximum repulsion we can say as the lone pair repulsion is going to is maximum. So obviously what is going to happen? The bond angle decreases from the ideal one. That means 109 becomes what? 104. Because of that, because of these two lone pair repulsion, the bond angle decreases from 109 to 104. Now if compare, look at this. Now if I want to compare as, listen, I'm taking, please understand very carefully, I'm taking as CH4 and NH3 and I'm taking is what? H2O. So can you compare the bond angle of these three? Very simple bond angle. Now carbon, what is the valence electron? 4 is the valence electron. How many hydrogens are there? 4 hydrogens are there. All what we can say going to form as a bond between that as a perfect tetrahedron. Look at this, I am writing C. Here is H, here is H, here also is H, and here also is one H. Now it's a tetrahedron. Now what is the bond angle between H? C H is what? The bond angle could be what as 109. Now come to the point of in the case of ammonia, look at this nitrogen. So one lone pair is there. Here look at this hydrogen. Here hydrogen. Here is what hydrogen. And observe that very carefully. Here perfect what we get tetrahedron. But here you have is what one lone pair is present. Because of the one lone pair, what is going to happen? Nitrogen, hydrogen. What is happening that? Yes, children. So listen carefully. Chemical bonding la pathing appadina edu bond pair lone pair solli thara first. Listen to. Now when I am going with that as let us take the example of this is CH4 and it is here NH3 and H2. இங்க பாத்தீங்க அப்படின்னா இதுல வந்து எத்தனை கோவேலன்ட் பாண்ட் இருக்குன்னு பார்ப்போம். கோவேலன்ட் பாண்ட் என்னது? ஷேரிங் ஆஃப் எலக்ட்ரான். லுக் அட் திஸ். இங்க C, here is what? H, இங்க வந்து H, இங்க H, இங்க H. நல்லா பார்த்துக்கங்க. இந்த கார்பன்ல சுற்றி எத்தனை பாண்ட் இருக்கு? 1 2 3 4 பாண்ட் இருக்கு. இப்போ 4 பாண்ட் நத்திங் பட் பாண்ட் பேர். இந்த 4 பாண்ட் பேர்ஸ் அண்ட் நோ லோன் பேரா இருந்தா அந்த மாலிகுல் இஸ் வாட்? பர்ஃபெக்ட் டெட்ராஹெட்ரல். ஐ கேன் சே திஸ் இஸ் வாட்? டெட்ராஹெட்ரல். சப்போஸ் இப்போ மாலிகுல்ல பார்த்தீங்கன்னா NH3 இருக்கு. இப்போ இந்த NH3 ல வந்து N, if as I can say one lone pair, here is H and H and H. இந்த எத்தனை பாண்ட் இருக்கு? 3 பாண்ட் இருக்கு. இப்போ இந்த 3 பாண்டுமே 3 பாண்ட் இஸ் பாண்ட் பேர் and this is what? லோன் பேர். அப்ப 3 பாண்ட் பேர் ஒரு லோன் பேர் இருந்துச்சு அப்படின்னா டோட்டல் நம்பர் ஆஃப் எலக்ட்ரான் பேர் என்னது? 4 எலக்ட்ரான் பேர். அது என்னது? 1 2 3 total number of electron pairs na including lone pair as well as bond pairs. That means 1 2 3 4 we can say that 3 bond pairs and 1 lone pair. Total number of electron pair is what? 4. Therefore but your expectation is what? If it is 4 electron pair means what? The bond angle enna varukanum? HCH bond angle is what? Would not mean should be there. But because of inga lone pair irukradhanaala the repulsion taking place. What type of repulsion? Adhu eppadi kandupidikiradhu appadina? Look at this, nitrogen and hydrogen. Which is most electronegativity? We can say that nitrogen is what? Most electronegativity. Obviously, all the electron pairs will go towards here. So now we can have the repulsion. There are two types of repulsion. Look at this. This is bond pair repulsion. This is lone pair, bond pair repulsion. So because of that, the repulsion now the bond angle வந்து கம்மியாயிடும். So expectation here is what? 109. When all are perfect, எல்லாமே bond pair and perfect bond pair mean what we can say as tetrahedral. But here you have that 1 lone pair is there and 3 bond pair is there. Because of 1 lone pair, the bond angle is deviate from original one. Now this becomes what as 107. Now in the case of H2, now H2 I am writing O. I can make it O. Here H. Here is what? H. I can have that lone pair. I can have that 2 lone pairs. I am having here 2 lone pairs. Here 1 lone pair, 0 lone pair. The molecular lone pair illana they have the perfect geometry. But because of the lone pair, they are deviating from ideal shape. Tetrahedral enava mari this becomes pyramidal. But still, this has the 2 lone pair of electron. But now, these two, you can say the repulsion takes place. And even though there are 3 types of repulsion is going to observe, 3 repulsion is there. One is lone pair repulsion. If you take the oxygen, hydrogen, which is more electronegativity, we can say oxygen is most electronegativity. Therefore, all the bond pairs will go towards here. Now we can say that. Now look at this. I can say here the lone pair repulsion. Lone pair, bond pair repulsion is there. Here we can say the bond pair. That means which is the most repulsion nadakum appadina? Lone pair. Because of that what? Bond angle decreases. The bond angle decreases from 109 to what? Now in exam what they will ask you? They may give CH4, they may give NH3, they may give H2O, which has the highest bond angle? CH4. Because perfect geometry. And H2O is the least bond angle. This is the order of what we can say bond angle. That's all. Now suppose if they are asking in terms of if they are asking in terms of, I'm going to check. If suppose if they are asking us, look at that. In the case of I'm taking PCFI, SF4, BRF3, XEF2. Now, in this case, I am taking these 5 molecules. These 5 molecules is what? In the Angela 5 molecule means 5 electron pairs. In the 5 electron pair, என்னென்ன possible இருக்கும் அப்படின்னா, one you can have as 5 plus 0, 4 plus 1, 3 plus 2, you can have that 0. இந்த 5 தான் possibilities. இந்த 5ல you can have 5 plus 0. What is the meaning of 5 plus 0? 5 plus 0 means all 5 are bond pairs. 4 plus 1, 4 bond pairs, 1 lone pairs. What about 3 plus 2? 3 plus 2 na 3 bond pairs, 2 lone pairs. What about 2 plus 3? 2 plus 3 means 2 bond pairs, 3 lone pairs. That means what is the shape you are going to get it? I can say when 4 plus 1 means you can say that seesaw. If it is 3 plus 2 means we can say as it's a bent T shape. Bent T shape. And I can say 2 plus 3 is nothing but it's a linear. How? So how? We know 5 plus 0, just now we have discussed. 5 plus 0 means trigonal bipyramidal. Trigonal bipyramidal. Fine, sir. Can you explain this? How do you say 4 plus 1 is seesaw? How do you say 3 plus 2 is bent T shape? How did you say 2 plus 3 எப்படின்னு சொல்றீங்க சார்? Look at this. I told you one method. Look at the logic. Now, I'm taking the simple example. This. Now, I'm going with SF4. I told central atom is sulfur. What is the valence electron of sulfur? 6. Yes. What is fluorine? What is the valence electron of fluorine? 7. 7 into 4, 28. 28 plus 6 is what? 34. 34 by 8 you keep it. What is that 34 by 8? That means 8 fours. That means 4 8s are 32. 4. Remainder is what? You have that 2. That 2 is nothing but what we can say 1 pair of electrons. I can say this is as bond pair. This is what? Nothing but that lone pair. In trigonal bipyramidal geometry, the lone pair always you have to keep in what we can say equatorial position to minimize the repulsion. Now I can keep S. I am giving this is F, this is F, this is F, and this is also F. Look at this. This I am keeping. This is one possibility, sir. If I am keeping here the lone pair in this equatorial position, the repulsion is what? Minimum. Now, because of this, the lone pair is present. The geometry is deviating from the original one. Therefore, this is called seesaw. This is called what? Seesaw. Now come to the point. The next will be BRF3. Look at this. In BRF3, what is central atom? Bromine. What is the valence electron of bromine? 7. What is the valence electron of fluorine? 7. 21. 28 by 8. You have is what as 3 8s are 24. Remainder is what? 4. That 4 considers a 2 lone pair of electron. Now we can say this is 3 bond pairs and 2 lone pairs. We know that in trigonal bipyramidal geometry, the lone pair always occupy only in which position? Equatorial position to minimize the repulsion. Now look at this. Now BRF3, we are going with that. BR. Now I can say here F. I can say F. Here is what F. Now That's all. This is BRF3 is the bent T shape. What is the method? BRF3 boron. What is the valence electron of boron? It's a bromine is what 7 valence electron and fluorine is what 7. 21 plus 7 is what 28. 28 by 8 is what 3 plus 2. Therefore, this is what T shape. If the lone pair is present, they are deviating from the ideal shape. Now look at that. Next will be. Now I am going with the next will be as XCF2. XCF2. In this XCF2, how to find out that the valence electron of xenon is what 8. What is the number of electrons of valence electron of fluorine? 7. How many எத்தனை fluorine இருக்கு? 2, 14. Which gives what is that? 22. 22 by 8. We can say that 2 plus 3. Why is that 2 plus 3? Very simple. 2 8s are 16. The remainder is what? 6. Therefore, 3 pairs of electron. So we can say that as Xc F all lone pairs are occupies in which position? Equatorial position. To make the geometry is what? The shape of the molecule is linear. If it comes 3 plus 2 linear, 2 plus 0 linear, they may ask which are the following isostructural. XCF2 is isostructural with CO2. Why CO2? 2 plus 0. See, look at this example. What example will ask? CO2. Very simple. Go with our method. What is central atom? Carbon. What is the valence electron of carbon? 4. Plus oxygen. எத்தனை oxygen இருக்கு? 2. Valence electron of oxygen is what? 6. 6 2s are 12. 16 by 8. And 16 by 8, 2 plus 0. That means 2 bond pair, 0 lone pair. That means linear. Then can we say about CO2, XCF2 isostructural. Iso are same, but they have same structure. But they are different hybridization. We'll discuss later. Are you able to follow? Next one. Look at this. In the case of 6. 6 means we have 2. One will be 6 plus 0. Another one is what? 5 plus 1. So what is the meaning of here? 5 plus 1. 5 plus 1 means 5 bond pairs. 1, what is that? Lone pair. And one more will be what? 4 plus 2. Okay, sir. This we have discussed. What about the 5 plus 1? If I am coming to the point of 5 plus 1, example is what? BR of 5. In BR of 5, please understand what is a bromine valence electron? 7. And fluorine is what? 7. How many fluorine is there? 5. So 5 into 7, 35. Which are going to get is what? 42. 42 by 8. You have is what? 5 plus 1. So what is 5 plus 1? Please understand. 5 8s are 40. Remainder is 2. And the 2 were 1 pair of electron. So now is nothing but I can say, listen. Here one pair. Fluorine. So this is called square pyramidal. If it is 5 plus 1 comes square pyramidal. Now take the example of next one. Now the case of 4 plus 2, I'll go with that. XCF4. In XCF4, please keep it in your mind. Xenon central atom, how much valence electron? 8. Fluorine 7. 28. That means 36 by 8. 4 plus 2. That means we can say that Xc 2 lone pairs above and below the plane. Here is one F, here is F, and here also is one F, Now this is nothing but a square planar. Over. That's all about the Vsepr theory. Now the next theory is called what? Hybridization. What is hybridization? Intermixing of atomic orbitals. Intermixing of atomic orbitals. That means when the atomic orbitals intermix, how it is intermixed? Look at this. When the intermix, which is going to produce the new hybridized orbital. Now let us take that. How the intermixing? We can say that S orbital can intermix with is going to, there are two types of overlapping. One we can say as a sideways overlapping and what we can say head-to-head overlap. This is called head-to-head overlap. It is called forming sigma bond. When sideways overlap, what is going to form? The pi bond. Look at this. I am going to give the how the sigma bond is going to form. Look at this. Now, yes, please what is it? Yes, it is going to form as this is s orbital. This is s orbital. This is nothing but yes overlap. This is sigma. Yeah, listen. Here, what type of overlap? SS overlap. When S orbital is going to overlap with head-to-head overlap. Now look at this. Now I can say this is P orbital. This is internuclear axis. Now here the P orbital can overlap with the other P orbital, which produces this is sigma PP. Now come to the point. This is yes plus this. This is S orbital. This is P orbital. You can have this. This is sigma. Yes. You can have sigma bonds. SS sigma bond, PP sigma bond, SP sigma. Which is sigma bond is stronger? PP is stronger. Why SS is not stronger sigma bond? The reason is what? The SS sigma bond, S orbital is non-directional. Due to that, PP sigma bond is stronger than SS sigma bond. That means order of sigma bond is what? PP stronger than SP, SP stronger than what? SS sigma bond. Now how the pi bond is going to be formed? Look at that. Now I can say take it as this is what the pi bond is going to form. That means sideways overlap, which is going to give us I can say this is E orbital, we are going to have P pi, pi bond. You look at this, sigma bond and pi bond, which bond is stronger? Sigma bond is stronger. Why sigma bond is stronger? Look at this. Right? When overlap takes place, you have as now look at this. This is the overlap of sigma bond. This is the overlap of pi bond. Where the maximum overlap? At the maximum overlap, the electron density is more. When the electron density is more, the nucleus is strongly attracted. When the nucleus is strongly attracted means what? The bond is very stronger. That means can we say this is sigma bond? I can say sigma PP. Now I can say the PP sigma bond is stronger than PP pi bond. Why? The overlap is minimum in the pi bond. That's all. Now what is hybridization? Hybridization means what? The intermixing of atomic orbital is called hybridization. That means before the bond formation, the orbitals are going to overlap, which produce the hybridized orbital. This hybridized orbital is going to take part in the bonding. The phenomenon is called what? Hybridization. Look at this. I'm taking the example to understand. So, listen. First, I'll give the simple idea. CH4 and CH4. How to do that, sir? CH4 I can say as a hybridization is what? sp3 hybridization. How we are going to say it's sp3 hybridization? Look at that. I'm taking carbon. Now, first I will explain. Then first I'll write it and explain you. What is the carbon? The valence electron should not say 4. We can say as a S2P2. S2P2. Ready? This is what? Carbon. In carbon, we should draw like this. Am I right or not? Now, how many hydrogens are there? 4 hydrogens. That means 4 bond pair is required. That means the 4 bond pairs means is what? I will tell you that. In excited state of carbon, the carbon has to have 4 unpaired electron in the orbitals. Now, if I excite that, listen. 1, 2, 3, 4. These 4 orbitals are intermixed, which produced sp3 hybridized orbital. That means these 3 orbitals means what? Look at this. This is called hybridized orbital. These hybridized orbital have their proper shape, tetrahedral shape. Now we have that I can draw. This is what hydrogen. Here is what hydrogen. Here is what hydrogen. Here is what. That means the hybridized orbital have what we can say the equivalent shape, the proper shape. When the overlap is going to take place, means the condition of hybridization is what? When the overlap of the atomic orbital must be the similar energy, or any difference is what? Very less. We can say 3p can overlap with 2p, but 1s cannot overlap with 3d. 3D and 1s is a zero overlap. So this is now how many hydrogens are there? I can say 4 hydrogens. Look at this. 1, 2, 3, 4 hydrogens are there. Therefore, this is called what we can say as sp3 hybridization. Now I'll give one method by using valence bond with the hybridization concept. Listen carefully. Now look at this. I'm taking one by one. I'm taking this BeCl2. If I'm going to write like this, first to go with the what I given the method, Vsepr theory method. First we will follow that will incorporate with hybridization. BeCl2, which is central atom beryllium. Look at this in beryllium. What is the valence electron? 2. What about the chlorine valence electron is 7, 14, 14 by 8. What we can say as 2 plus 0. What is the meaning of 2 plus 0? 2 bond pairs and 0 lone pair. Now compare the hybridization. Take the beryllium. What is the valence electron of beryllium? It's nothing but a CS2. Am I right or not? Now we can say that beryllium which has that empty orbital. Look at that. You can say this is 2 electrons there. Now as per this, as per the Vsepr theory, how many electron pair is required? 2 electron pair. 2 electron pair means what? 2 bond pairs. This is nothing but in the excited state of beryllium, they should have 2 unpaired electron. Now I have the one what we can say pair is there. I require one more pair is to excite that. Listen. Now if I excite that, that's all. I got it. Now I have how many chlorine is there? 2 chlorine. The chlorine, what is electronic configuration? I can say that chlorine is what? I can write that S2P5 for chlorine. That means this one electron is going to take what in the order we can say hybridization. Look at this one electron, this one electron, this one electron coming from is what? Chlorine. That means sp sigma and pp sigma bond is going to be formed. That means this is what is going to form the hybridization. Can we say if it is 2 plus 0 comes, what is the hybridization? Sp. That's the reason your ID is what? BeCl bond. What is that? Cl. So this is going to form a sigma bond. Sigma bond only is considered for the hybridization. Pi bond you won't consider for hybridization. Next, look at that. If I am going with same thing, now I can give you. Please keep it in mind. Whether if it is 3 plus 0, sp2, we can say that 4 plus 0, 3 plus 1, 2 plus 2 will be sp3 hybridization. We can say that 5 plus 0, 4 plus 1, we can say that 3 plus 2, we can say that 2 plus 3, nothing but sp3d hybridization. Number 5, if 5 comes sp3d. If number 6 comes sp3d2, yes, p3d2, 6 coming. Suppose if I am having 6 plus 0, we can say that 5 plus 1, we can say that 4 plus 2, we can say that sp3d2. If it is 7 plus 0, 6 plus 1, we can say that sp3d3. That's all. How that Vsepr theory is linked with hybridization. If it is 2 means sp. If it is 3, sp2. If it is 4, well, 4 means 4 plus 0, 3 plus 1, 2 plus 2 is going to give sp3 hybridization. If it is 5, sp3d. But if it is 5, PCl5 and SF4, both have same hybridization but different shape. Because SF4 is what? Seesaw. That is what you need to understand here. Now come to the point. I want to explain the remaining thing. Listen. Now, I want to discuss with that. I am taking as PCl5. PCl. First, go with that our Vsepr theory method. What Vsepr theory says that central atom is what? Phosphorus. What is the valence electron? 5. Now, what is the chlorine valence electron? 7. 7 into 5, 35. I can say 40 40 by 8 is what? As 5 plus 0. 5 plus 0 means what? I can say 5 bond pairs and what? 0 lone pair. That means in the phosphorus, in excited state, they should have 5 unpaired electron. This 5 has to come here. How? Look at this. Phosphorus. You can see that S2P3. Now come to the point S. Taken that. Now we know that phosphorus has presence of empty d orbital. Now you have how many bond pairs required? 5 bond pairs. We have the 5 bond pairs means what? Phosphorus has to give 5 unpaired electron. Chlorine has to give the 5 unpaired electron to make it what we can say as a sigma bond is going to form. Which means that what? That each phosphorus has to give 5 unpaired electron and there are 5 chlorine. Each chlorine can give 1 electron to make PCl5 bond. Now look at this. If I excite the pair, 1, 2, 3, 4, 5. Now I am having how many chlorine is there? 5 chlorine. Each chlorine 1 unpaired electron. That's all. Now this all is going to form is what as sp3 sp3 dehybridization. What is sp3d means what? Trigonal bipyramidal. And even I can say even if it is presence of lone pair, how to find out the hybridization? Look at the same logic. I am going with that as in this case. I am taking. Let us take that BRF3. BRF3. If I am going BRF3, what is the bromine? We will have that 7, 21. You can have that 28 by 8. You can say that 3 plus 2. 3 plus 2 means what? 3 bond pairs and 3 bond pairs and 2 lone pairs. Write the bromine electronic configuration. Look at this. S2. I am going with that P5. That's all. Now, please understand. You want to get only 3 bond pairs and 2 lone pairs should be present here itself. Now, what I am going to do? I am exiting only this pair. Look at this. That's all. Even the non-bonding electron pair also take part in the hybridization as a non-bonding electron only. Now, if all this, if I together, if I am going to get it as S P3 D, but shape is what? As a bent T shape. PCl5. If I am coming 3 plus 2, total is what? 5. If it is 5 comes sp3d, but the shape only, geometry only is what differs. PCl5, trigonal bipyramidal geometry, and this is belongs to what we can say here, T shape, because of what? These two lone pair, which makes the repulsion. That's all. Now come to the point about, in this case, suppose in exam, what they will ask you? They will ask you, in exam what they will ask you? Let us take, they are taking CO2 and SO2. CO2 and SO2. They are asking how many pi bonds are present. The pi bonds are belongs to what? CO2 and SO2. They have how many pi bonds are there? The pi bonds are belongs to what? Pi bond belongs to what? Mean whether it is p pi, whether it is p pi, d pi, or d pi, d pi. That's what they will ask you in the exam. Now I am going with that CO2. I'll tell you how to first to go with the Vsepr theory. Very simple. What is 4? 4 plus 12, 16. 16 by 8 is what as I can say as 2 plus 0. That means they should have the 2 bond pair should be present in the excited state of carbon. I'm making carbon is what? S2P2. Now look at this. That means 2 means what? It should be sp hybridization. Look at this. I have taken like this. Now that means to get the sp hybridization, S orbital should have the unpaired electron, but here the pairs of electron. I want to excite the electron from here. Look at this. When I excite that, like this. Look. Pi bond is not considered for hybridization because overlap is very less. Now, but how to find out how many pi bond is formed? I told you that here that only that two bond pairs. This two is indicated sp hybrid. That means CO2 belongs to sp. The sp na right. This is two only going to form a sigma bond. These two are going to form pi bond. How? அப்போ ஒரு ரெண்டு பாண்டில் கண்டிப்பாக ரெண்டு சிக்மா பாண்ட் இருக்காது. ஒரு சிக்மா இருக்கும், ஒரு பை இருக்கும். எப்படி சொல்லி தருவாங்க? Listen. CO2. You have two oxygen are in two oxygen பார்த்தீங்க அப்படின்னா you may have like this. This is one oxygen. This is what? Another oxygen. So this is going to form sigma. This is going to form is what? Sigma. Pi. Pi. And look at this. This is going to form this. Pi. That means p orbital of oxygen is sideways overlap with p orbital of carbon forms pi bond, and p orbital of oxygen and s orbital of carbon forms sigma bond. P orbital of oxygen and p orbital of carbon form sigma. Therefore, we have the two bonds forming each what we can say oxygen. That's the reason we are writing C double bond O sigma pi sigma pi. You have that two sigma bonds and two pi bonds. The two pi bonds that belongs to this is P from oxygen, P from what? Carbon. This also P from oxygen. This also P from carbon. Can we say this has two P pi bonds? Now, what about in the case of SO2? Listen carefully. In the case of SO2, same logic I am going. What is sulfur central atom? What is the valence electron? 6. 6 plus 12. You can have 18. 18 by 8 means you can have that 2 plus 1. The 2 plus 1 means what? 2 bond pairs and 1 lone pair could be sp2 hybrid because 2 plus 1 is equal to 3. 3 means what? sp2 hybridization. Look at that. Now I am going with that as sulfur. This is S2P4. And look at this. We know that sulfur has presence of empty d orbital. Now I want two bond pairs and what we can say one lone pair. Therefore, I have the two lone pair is there. Therefore, one I am going to excite that. Therefore, one I am keeping to for the hybridization. Taken that. Now, 2 plus 1. That's all. 2 plus 1 is involved for what? Hybridization. How many oxygens are there? I have 2 oxygen. We can say that 2 oxygen is 2p4. So I can write it as 2 unpaired electron for each oxygen. Comes like this. Now look at this. This is going to form a sigma bond. This is for what we can say sigma bond. 2 oxygens are there. Now one oxygen is going to form. This is pi bond with sulfur. P orbital of oxygen. P orbital of sulfur is going to form pp pi bond. And look at this. This is I can say that p orbital of oxygen and the d orbital of sulfur. What is going to form? P pi d pi pi bond. So in the SO2 also you have 2 pi bonds, but the 2 pi bonds are different. One is p pi, another one is p pi d pi. Therefore, this is as p pi or p pi. That's all. This is what the logic. But in the exam, they are asking XeO2F2. They will ask you what is the hybridization of. Look at this. They may ask you sum of. What we can say? Sum of, or we can say how many pi bonds are present. The pi bonds are belongs to is what in the case of XeO2F2. Look at this. XeO2F2. The logic. XeO2 and F2. Oxygen can form pi bond. Oxygen can form pi bond. Sulfur can form pi bond. Right or not? So now look at this, how to do that. Very simple. Go with the Vsepr theory method. What is xenon? 8. Oxygen is what? Valence electron is 6, 12, 14. What do you have as 34? 34 by 8 you have is what? 4 plus 1. When 4 plus 1 means hybridization is what? sp3 dehybridization. Now take it, xenon. Oh, now required is what? 4 bond pairs, you have 1 lone pair is required. Now what I'm going to do? 1 lone pair I'm keeping here. This everything I'm going to excite. And excite that. Now I excited. Listen carefully. This is only for what? As a bond formation, you can say yes. Because I can have the fluorine, 2 fluorine. When you can say this is sigma, this is sigma. 2 oxygen. 2 oxygens are there. You can say that oxygen, oxygen, sigma. This also is what sigma is going to form. Now look at this. This is P5, D5. This is also P5. That's all. Now in XeO2F2, you have that in central atom, how many lone pairs are present means only 1. But if they are asking total number of lone pair present on the entire molecule of XeO2F2 means think about it. You should draw like this. Xe and give you what F. Here is what F. Here is what lone pair. Double bond O. Double bond O. If the central atom has how many lone pair means? Answer is 1. If they are asking total number of lone pair present in the XeO2F2 molecule means you should consider look at this. Now I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have the 11 lone pairs of molecule present in the entire molecule of XeO2F2. If they are asking total number of lone pair present on the central atom of xenon means is what? 1. They are asking the entire molecule means you should add everything. Because what? Fluorine S2P, S2P5. That means 1 electron take part. That means 3 lone pairs are present. This is what? S2P4. Therefore 2 is involved. Remaining 2 is there. Are able to follow? This is what at the examination point of view they will ask you that. Now can you go one question they may ask you? They will do like this. They will ask you sum of lone pair, or I can write lone pairs present on central atom of the following molecules. Sum of the lone pairs present on central atom of the following molecule. Look at this. I am going one by one. I will give the molecule. First will be N2O, then Vsepr I3 minus and XeF6, then Xe F4, XeO F4, ICl4 minus, like that is given. So if these molecules are given, they will ask you to find out total sum of lone pairs sum. Okay, sum of lone pairs of present on the central atom of for the following sum we have to add one by one. First I am going into O. Go with the my method. Very simple method. Find out central atom is what here. Even nitrogen is central atom. Two nitrogens are there. 10. 10 plus 6 by 8. You can have is what? 2 plus 0. So no 0 comes means no lone pair. Now yes. Sulfur. Central atom is sulfur. We can say 6 plus fluorine is what? We can say 28. 28 by 8. You can have is what? 4 plus 1. We can have that one lone pair. Now come to the point of I3 minus. I3 minus is what? Iodine. Whenever minus is there, you should add one electron. Iodine is what? 3 iodine. 3 into 7, 21. Already minus is there. That means you should add one electron, 22. 22 by 8. You have is what as 2 plus 3. You have the 3 lone pairs of electron. Now XeF6. Xenon is 8. Fluorine is what? 42. That means by 8. You can write as here 6 plus 1. Can have is what? As 6 plus 1. As 6 plus 1. And what about XeOF4? Look at this. I am taking as here. XeOF4. Xenon is what? 8. 8 plus 6. 6 plus 28. 42. That means 8. You can have is what? 5 plus 1. And ICl4 minus. Look at this. ICl4 minus. You have is what? Iodine. Iodine is what? 7. 1 electron. Add 8. 8 plus 28. 8 plus what we can say? 8 plus 28 by 8. You may have is what as 4 plus 2. Now if I do the sum, 0, 1. 1 plus 3, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 2 is what? 8. And there is what? 86. This is these type of questions you may expect. Next one. Which of the following pairs of molecules are isostructural? Next question. I'll give you. Which of the pairs of molecules are isostructural? I'm going to give you next question. Look at this. Which of the pairs of molecules are isostructural? I may use a multi-correct also. Look at this. Which of the following pairs molecules? Which are the following pairs of molecule isostructural? Isostructural means what? They have that same shape. Look at that. Like this is given. I can say that how to go with that. Find out the central atom. If the central atom has same bond pairs and the same lone pairs, they have definitely what we can say same shape. Like the example of BeCl2 and CO2. Central atom is what? B is 2 plus 14 by 8. What you have? 2 plus 0. Take CO2, 4 plus 1 is 16 by 8. And say 2 plus 0. So this also 2 plus 0, this also 2 plus 0. So both is what? Isostructural. Now come to the point of XeF4. XeF4 is what? And the E is 8. 8 plus 28 by 8. We have is what? 4 plus 2. ICl4 minus, you should add an electron. That means 7 plus 1, 8. 8 plus 28 is nothing but 4 plus 2. And this also 4 plus 2, this also 4 plus 2. Or we can say they are square planar. Now come to the point of NH3 and XeO3. We know that NH3 is what? 3 plus 1. XeO3 also 3 plus 1. Look at this. 8 plus 18. You have that 26 by 8. You have that 3 plus 1. They have isostructural, but they are isoelectronic. And look at this CH4 and SF4, both are not isostructural because CH tetrahedral, SF4 is CISA. So these type of questions only you may expect in the examination point of view. Next one is same. Which of the following molecules are the pairs of molecules same hybridization, but different shape? Which of the following pairs of molecule is what? Same hybridization but different shape. Look at this. Now, which of the following molecule, which are the following pairs of molecule has same hybridization? Same hybridization but different shape. They have same hybridization but different shape. Yeah. I3 minus Br. SO4 CCl4. Option C. Ladies and gentlemen, sir, pairs of molecule have that same hybridization differential. Our answer is what? A is the answer. Why sir A is the answer? I3 minus Br3 if we take, you are going to get for I3 minus, if we go with our method, you may get as 5 electron pairs. 5 electron pairs. But here is what 2 plus 3, here is what 3 plus 2. They have the same hybridization sp3d, but linear T shape. SF4 both have different hybridization because SF4 is sp3d. This is CCl4 is sp3. Therefore, this is ruled out. Now NH3 and BF4 minus. NH3 and BF4 minus have same hybridization. I am asking have it has same hybridization NH3 and BF4 minus. Why NH3 is pyramidal? This is what we get tetrahedral. Therefore, C is right. Same. This also sp3. This also is what sp3. And look at this BRF5 and IF7. BRF5 is nothing but sp3d2. It's a square pyramidal. And IF7 sp3d3. How's that? Look at this. IF7. Go with that. Central atom is what? Iodine. What is the valence electron of iodine? 7. 7 plus 49 is 56. 56 by 8. 7 but is what? 7 plus 0. And 7 means what we can say? Pentagonal bipyramidal hybridization sp3d3. How? Look at that. I want to clean this. IF7. So 7 plus 49, 56, 56 by 8. We can say as 7 plus 0. Now iodine central atom is what as S2 A5. So now what I am trying to say that how many as per the Vsepr central atom should have 7 unpaired electron in the excited state? You have only one. These 3 I have to excite that. So now we have how many fluorine are there? 7. So all can take part in the hybridization which produces what? Yes, P3D3. That's all. This is what I can tell to you children. So I have some geometry we can write as I yeah. Make it as IF7. This is what in examination point of view they will ask you. So this is about IF7. Now you want to go with that as last only one question. Find out total number of non-bonding electron present in XeOF4. Total number of non-bonding electrons. Total number of non-bonding electrons present in the entire molecule of XeOF4. This is very important. and XeOF4. So what we have to do first, go with Vsepr theory method. What Vsepr theory says that, you can see that 8 plus 12 is 140. We are going to have is what 20, 34, 34 by 8. We have is what as 4 plus 1. 4 bond pairs, 1 lone pair. Apart from that, listen carefully. Xenon. So F, this is F, and this is F, F, double bond O. Right, and you have that one more lone pair is there. 254. 4 sevens are 28. Extremely sorry. So you are going to get as 38. XeOF4. Imagine some calculation mistakes. XeOF4. So fluorine is what? 7. 7 4s are 28. Oxygen is what? 6. Is 8. Now 14 and 28. We can have is what? 40. So 42 by 8 can have that 5 plus 1. That means let's see, one lone pair is there. Fluorine, fluorine, double bond O, F, and F. Each fluorine has now can we say 1, 2, 3, 4. 4 into 6 is what? 1. Each, what we can say? I can say one fluorine has 3 non-bonding. 1, 2, 3, 4. That means 1. Oxygen has is what? 2. And this has 1. Total is what? 15 non-bonding electron pairs is present in one molecule of, what we can say, XeOF4. That's all. These type of questions you may expect from JEE mains. So thank you. Remaining thing will be chemical bonding and discuss class. Thank you, children.